In our previous videos, we've talked about quadratic forms and representing a quadratic form using a matrix. In this video, we're going to talk about how to maximize the value of a quadratic form, or minimize it. So what does that mean? So say we're told that A, as in the matrix A from x transpose times x, so this is our representation of our quadratic form. This symmetric matrix A, we're told, let's say we're told that it's, I don't know, 4, 2. And we're told that the value of x transpose x multiplied together, or, yeah, I mean dot product did, or has to be equal to 1. And we want to maximize the value of x transpose A multiplied by x. So the way we do this is we start by finding the eigenvalues, which can simply be identified because they're on the diagonal, as lambda 4, lambda is 2. And then with these, we can identify eigenvectors, which in this case I think will just be 1 and 1. And ordinarily we normalize those vectors to be of length 1, but, well, they're already of length 1. And then we just plug in these vectors as x, and we figure out which eigenvector maximizes the value of this matrix. And in this case, it's pretty easy. We find that the maximum value of this top term here, of this quadratic form, in this condition is 4. And the minimum value is 2. And it's quite straightforward with a matrix where the only entries are on the diagonal. And of course, we've learned how to create matrices where the only entries are on the diagonal when we set x to be equal to py. So essentially we can find the maximum minimum value of any of these quadratic forms by using the change of variable operation and then by identifying the eigenvalues and eigenvectors. In this video we talked about maximizing and minimizing the value of a quadratic form. And before I finish, one thing I failed to mention in my video on positive, semi-definite, and definite, and indefinite is that you can, if a matrix has all of its eigenvalues are positive, you know it's positive definite. And if all the eigenvalues are negative, you know it's definite neg. And if you have a positive and a negative eigenvalue, you know it's indefinite. And that's a very important trick for saving time. Thank you for listening.